Yeah, hi, I'm Tom. I work at HashiCorp. I'm here to talk about infrastructure as code with Terraform on Azure. Not that. Just out of interest, who's using Azure so far? Okay. And who's heard of Terraform before? Cool. Is anyone using Terraform? Okay, cool. Yeah, so I've been working at HashiCorp for about 2 years. We're just coming up to 2 years working on the Azure provider primarily. HashiCorp make a suite of products which are focused on the application lifecycle. You may have heard of a few of them. Vagrant, Packer, Terraform, Vault, Nomad, and Console. This talk specifically is about Terraform and Terraform on Azure. But hopefully, hopefully the principles should apply to any of the other providers that Terraform supports. So, just to get started, what is infrastructure as code? Infrastructure as code is declaratively defining your infrastructure in code in such a way that you can apply standard software development techniques to it. So for instance, you can apply code review and continuous integration to your infrastructure. This also means that you can spin it up in other regions as needed, and your infrastructure is documented, and also you can ensure it meets any policy requirements. So for instance, if you only need to be in specific regions or specific instance sizes or whatever it is. There's also cloud-specific versions of infrastructure as code, each cloud offers its own kind of provisioning system. So for instance, in Azure, that is an ARM template. AWS has CloudFormation, Google has Deployment Manager. There's a whole bunch out there. So what is infrastructure as code with Terraform? So Terraform provides a DSL that's known as HCL, or the HashiCorp configuration language, which is kind of JSON-like. So if we take a quick look at some HCL, this is two resources built with HCL, which creates a resource group and a virtual network within Azure. Within this, so in the resource group name, we define a couple of parameters. Same thing for the virtual network, and we thread some variables through. So in this case, we thread through the name of the location from the resource group, or not. We're back. Cool. So we thread through that. And in this example, it means that you can define things once. So in the case of Azure, you need to thread through a resource group name into just about every resource, and also the location field on a bunch of them. And so rather than typing like West US or Australia South through every resource, you can reference it once at the top. We'll come back and break this down in a moment. So HCL provides a common language which allows you to provision resources using any provider, across any provider. But that raises the question, what do we mean by provider? So Terraform supports over 80 officially like HashiCorp supported providers. And it's possible to write your own too. There's about 80 plus community providers, and I just want to call out a few of them. So Terraform supports clouds, so the big names like AWS, Azure, Google, but also some smaller ones like Scaleway, This also covers things like DNS, so DNS Simple Power DNS, and also some PaaS services, so you can like mix and match these things, which is quite nice. It also supports running stuff on premise, so Azure Stack and vSphere for any existing infrastructure, which means you can mix and match Terraform how you want. What's quite nice is because the way Terraform works, if you have a CRUD API, you can basically build a Terraform provider for it. And so whilst what I'm covering is Azure specific today, you could plug anything together. So if we go back to the snippet we saw earlier, this is a smaller section of that. If we break this down a little bit, the first word here, resource. So Terraform supports two types of thing. There's a resource and a data source. So a resource manages something. So in this case, it provisions a resource group in Azure. We'll come to a data source in a bit. there's then a name of a resource. So in this case, this is the name of the Terraform provider, so as your RM, and then the type of thing. So resource group, virtual network, subnet, whatever it is. We then have a friendly identifier for Terraform. This is completely unrelated to your code. It's just an internal reference. So this could be main, this could be test, this could be whatever. But you use this when you reference resources from one another. We then have the properties within that resource. So in this case, these are required properties on a resource group. So the name and the location. This omits any optional ones, but you can optionally specify like tags for a resource group or whatever they are. Bring all this together. This is kind of what a resource group, this is what a resource looks like in Terraform. But how do we actually provision that resource group? So Terraform is a command line application, so we can just run it, download it and run Terraform. And by default, if you just run Terraform, it's going to show you what commands it supports. I want to call out a few of them here. So apply, destroy, init, and plan, which we're going to go through. So Terraform init is the first thing you run, and that basically looks at the code that's on your in your current directory, and works out what providers you were using. So in the case of the code I showed earlier, we're using Azure. And so Terraform's going to go ahead and download the Azure binary, Azure provider, and downloads any modules, which again we'll come to in a bit. This basically prepares the working directory. Yeah. Next up, we have Terraform Plan, and what this does is to work out the state of the world. So it looks at the configurations you defined locally, it looks at the state of the world in Azure, and it goes, does this resource group exist? And in this case, the resource group exists locally in the Terraform config, but it doesn't exist in Azure. And so Terraform wants to create that resource group. You can optionally output this plan to a file as well. So if you're like running your account, which may not necessarily have admin rights to do this, you can save that plan and then pass that to someone who does. Next up is Terraform Apply. And so this will, by default, will actually run Terraform Plan. And so you can optionally pass in the plan, it won't do this. But again, it's going to run a plan and go, hey, here's what I want to do. Should I go and make these changes? So whilst Terraform's doing that, Terraform's going to output the progress of what it's doing. So in this case, we're provisioning a resource group, which is pretty quick, like 4 seconds. So it's not going to sit there and wait. However, for longer operations, like when you're starting a VM, it's going to sit there and show what it's doing. What's quite nice is if you're using multiple resources and they can be performed in parallel, Terraform knows, for instance, that if you create a virtual network with 3 subnets, it knows it needs to create the resource group first, then the virtual network, but it can create the 3 subnets in parallel. And so Terraform can speed things up where it's possible. Okay. So as we've run Terraform Apply at this point, if we rerun Terraform Plan, the state of the world in Azure, so the resource group, will exist, and it exists locally, which means Terraform will have nothing to do, which, yeah, happens. One thing of note is that because when you do a Terraform Plan, Terraform reaches out to Azure, or whatever the provider is, and goes, does this still exist? If someone were to manually make changes within Azure, or manually delete the resource group in this case, Terraform would detect that and say, hey, I need to remove the tag, or I need to recreate it. Yeah, and then the final command I want to just call out is Terraform destroy. This is really helpful. So I know of people who are spinning up entire environments, like a Kubernetes cluster at like 7 a.m. before everyone gets into the office. Everyone does work for the day, and then it gets torn down at 7 p.m. It's really handy, like not having to log into the portal or the CLI and like randomly delete things. Terraform can work out the order of what needs to be destroyed where. So, yeah. Again, Terraform's going to give you a plan, and yeah, if you enter yes, if you say yes, Terraform's going to do that. Yeah. So I wanted to give a demo of this just because, yeah. Mirror displays. So there's a repo for this that's on GitHub. I will open source it after this talk. Can you all read that? Cool. So there's a couple of things here I want to call out. The first is this provider block. So we support, there's a version of Terraform Core and there's a version of a provider. So in this case, we release them independently. So you can use any version of any provider you want and any version of Terraform you want. In this case, we released 1.15, I think it was last week. But you can upgrade this how you want. So in this case, we create a resource group with an identifier example, and in the Australia East region. We then thread that through here with the interpolation syntax. So this is the squigglies here. And this is the name of the resource. So in this case, the resource group. The name of the identifier, which as I mentioned is Terraform internal only. And then whatever property you want to access. So in this case, name or location or whatever else it is. So if we go to a terminal, maybe not that. Right now, sorry, this is the file that we had open. So yeah, the first thing we would do is to run Terraform init. Oop. And what that's going to do is say, we're using resources in the Azure RM provider, which is the Azure provider. And so Terraform needs to go ahead and download that. So it's going to go and do that. Hopefully the internet works. Maybe not. Cool. Okay, that's relieving. Yeah, so the next thing we can run is Terraform plan. And what that's going to do is to work out, as I mentioned, it's going to query Azure and go, hey, locally I should have a resource group and a virtual network that exists. Does that exist? And so in this case, they don't. That's better. Yeah, so in this case, they don't. So Terraform's going to say, I'm going to perform these actions. And so I'm going to create these two resources. You'll note down here it says 2 to add, 0 to change, 0 to destroy. We'll come to that in a minute, but Terraform will show you what it's going to create, what it'll destroy, and what properties change. So if we run Terraform Apply, it will fail because my keyboard. Cool. Sorry, I have one of these new Mac keyboards and yeah, sticky keys. Cool. So again, Terraform's going to say, hey, here's what I think I should be doing. Is that okay? What's quite nice with this is you could set this up on a CI server to go, hey, has anyone made any manual changes? Yeah. So cool, that's going to go ahead and do that. As you can see, it's create the resource group first and then the network. Terraform can infer the ordering based on the config. So by using this interpolation syntax, you're telling Terraform that this resource group needs to exist first. It's worth saying there's documentation for all of this. Where are we? If you go to terraform.io, there's a list of providers, and then Azure. And you end up on this page, which gives you example usage of how to get started. There's data sources which we'll come to in a minute, but one of them virtual network. So if you scroll down on the left, Terraform will give you example, or the website gives you example usage of how this works. And there's properties listed as well. So this this mostly matches the Azure documentation. Yeah. So as you can see, one of the properties here is tags. And so because we've not specified any tags at this point, there are no tags on the resource. But if we go ahead and add some, so tags NDC, Sydney, yep, and rerun the Terraform plan, Terraform is going to detect that these tags don't exist in Azure, they do exist locally, so Terraform is going to say, hey, we should add these tags. And what you're seeing here, the refreshing state, is Terraform calling out to Azure to go, hey, like what's the latest state of this resource? So I mentioned earlier about want to change. This is where Terraform will say, I currently have no tags on it. There is one tag to add, and so I'm going to make that change. So if we run Terraform Apply, that'll add those tags, and we'll go back to a good state. Connection issues. Cool. So Terraform then modifies that. So cool, which means it's now in sync. So if we were to rerun Terraform plan, Terraform will go, there's nothing to do, which is nice. So, right, mirror displays. Cool. So just to recap, there's 4 commands that are kind of most important in Terraform, which is Terraform init, which downloads the providers and basically sets the working directory up. Terraform plan, which determines what needs to be applied. Terraform Apply, which then makes those changes, and Terraform Destroy, which will tear things down. You may not necessarily want to run Destroy all the time, but it's helpful to have it. Yeah. Cool. So, I hear you say, Terraform's all well and good, but I have a ton of existing resources with provision by the CLI portal, ARM templates, whatever. How can I work with them in Terraform? And so Terraform has 2 means of doing this. The first of those is a data source, and so a resource earlier on was creating and modifying a resource with Terraform and managing it effectively. A data source is referencing information about that. So if you were to have, for instance, like a core networking team who created a virtual network for you and said your subnet is foo, you can just specify foo. They can manage it however they want, and you can basically build decoupled systems this way. Or decoupled infrastructure. So in this case, it's very similar to creating a resource. So this is a data source. The main difference between a data source and a resource is the word data rather than the word resource. Yeah. One thing of note about data sources is they expect the resource to exist. And so if it doesn't, Terraform will throw an error and say, hey, the resource group existing network should exist, but it doesn't. So, yeah. Whereas a resource will create it. So in this example, we just output a variable. So in this case, the address space of the network, the CIDR block. Yeah. And as I said, you can build decoupled configurations this way. The other option is importing. So if you have this resource you provision through the CLI or whatever else, you can then bring that to Terraform and have Terraform manage changes going forward. So the way you do this, Terraform has another command. So Terraform import the resource name, an identifier, and then the actual Azure resource ID. In Azure, these are a bit long, but in other providers, it's, yeah, a bit easier to read. Yeah. So again, Terraform import will go look that up, bring this into the state, and you have it locally. But what's quite nice is each resource on the Terraform website says how to import it. And so in this case, sorry. And so import functionality is opt-in, but almost everything the Azure provider supports it. There are a couple of cases where there's no way of getting the information once you've created it, like a service principal credential. But yeah. So I wanted to demo how to do that. So in this case, where are we? Here we go. So in this case, there's a virtual network that exists called NDC Network Resources, or NDC Shared Network, sorry, which is this one. Come on. It's always the internet. Always the internet. Come on. Right. So if we go to one, cool. I've rerun Terraform init here just because there's a couple of these and it takes a while. So if we run Terraform plan, again, what that's going to do is to look this up in Azure and go, hey, this exists. So I'm going to create this subnet for you eventually. Cool. But because this is just a resource, so Terraform will only say I'm going to create this one thing. This is just the subnet. Because we are referencing the virtual network that already exists, Terraform won't try and create it. So we can run Terraform Apply here. That's then going to create the subnet. And yeah, it'll leave the virtual network as it is. So what's quite nice about this is it means you can lock the permissions down as well. So you could say the user who provisions Terraform, or the app ID that provisions Terraform only provisions this thing, only has access to this resource group or this virtual network or whatever it is. Come on. Cool. And just because it's good to confirm these things. We're there. Cool. So that works. So that's nice. But if you take a better example here, so Kubernetes is quite popular at the moment, put it mildly. So a Kubernetes cluster takes a little while to spin up. And so you might have a long-running Kubernetes cluster, or spin it up at the start of the day or whatever it is. With Terraform, where I mentioned it supports multiple providers, you can chain things together. And so in this case, I'm looking up an existing Kubernetes cluster, which is here. And I want you. And we're going to use the credentials from this to provision a namespace in Kubernetes. And the way we do this is by, so I've run these two commands locally just so we can show the Kubernetes portal. But the way we're going to do this is to thread the credentials from AKS. So Terraform supports creating an AKS cluster, but it also exports the Kubernetes config, so the host, the password, the secrets, etc. And so what we can do is to say, take the output of AKS, so the credentials, and then thread that through to Kubernetes, so that when I create the namespace, it'll create it in the AKS cluster, which means you can spin the whole thing up in one go if you want, or independently. So in this case, if I run Terraform Apply, that's going to go ahead and reach out to AKS, reach out to Azure, get the AKS credentials. Come on. And then create the namespace in Kubernetes. What's quite nice is you can do this with anything. So you could take a DNS record, take your DNS from Azure and put it into Cloudflare or whatever you want to do. And if we refresh the namespaces, not that. Come on. The namespace exists. So you get the same plan apply functionality across any of the providers, which is really nice. And again, if someone were to go and delete that, I forget how you do that in Kubernetes, but yeah, if someone were to delete it, Terraform would pick up that it's gone. And again, I can run Terraform destroy. Terraform's going to go ahead and go, hey, this namespace no longer exists, so tear it down. Cool. So in this case, yeah, it says there's one thing to destroy. So this is because we're using a data source for the AKS cluster, it's going to leave it alone and just destroy the namespace. One of the nice things as well is you can chain providers together. So you can have two Azure providers, one connected to a CI subscription, one connected to a staging subscription. if you wanted and create virtual networks between them that way. Yeah. Final thing I wanted to cover was importing. These IDs are a bit long, so I'm just going to copy and paste that. So with importing, I have an existing, there's a resource group that exists in Azure called NDC Sydney Manual. If you write the Terraform configuration for this right now, Terraform thinks this doesn't exist. So one of the things I can do is to do Terraform import, and then the name of the resource, in this case is your resource group, dot the friendly identifier, which here is example, and then the resource ID. Ooh, not that, apparently. Example. And so what Terraform's going to do again is to look up the state of the resource group in Azure and to bring this in locally. Cool. Which means that going forward, if I were to make changes to, if we were to add a tag, and run Terraform plan, Terraform is then going to detect that it needs to add that tag, and as you saw earlier. Come on. Cool. Okay. So, yeah, as you've seen, we can connect any provider together. So we can take information from AKS and put it into Kubernetes or whatever combination we want, which is really handy. The final thing I want to cover was modules. So if you have all these Terraform configurations, how do you stop yourself like copy pasting them all over the place? So you can take, so in Terraform a module is a directory full of .tf files. So everything we've created thus far is actually a Terraform module. It's just not been referenced in that way. And a module can have inputs and outputs. And it can also come from multiple sources. So you could source it from a local file system. You could have a Terraform module in a Git repository or in a module registry. In Azure, an example of like the inputs and outputs would be the resource group name because it's on basically everything. Yeah. So in this example, we have the module coming from a local file system. So I have a folder called modules and then example. You can do the same thing from a Git tag. So you can create a Git repo with Terraform files in it and reference that internally. And there's the module registry too. There's a few of these. So we have this thing called the Terraform module registry, which is like a public source of information, a public source of Terraform modules. So if you want to find a security group for AWS or I don't know, how to spin up a function app in Azure, there's a Terraform module for that. There's also a private module registry which you can set up internally for your own organization, and it's an API, so it's documented. Yeah. So I just wanted to demo reusing code in a module. So where are we? Cool. So this example is a little bit bigger than the ones we've seen previously. So I have two modules here. In fact, I have a few things. So we have provider block as before. We have a local block which just does some interpolation for us. It's a different kind of variable. We create a resource group. And then there's two modules here. There's one for a virtual network, and there's one for a virtual machine. And what we're going to do is to output the value of the admin username and the public IP address from the virtual machine. Excuse me. So if we look in these folders, these are just regular Terraform modules as we had earlier. They have a couple of variables in them just because it's convenient to do that. So in this case, I pass a prefix. Sorry, I should explain. So you can define a variable in Terraform like this. So variable, name, whatever. You can optionally set a type on it as well. It's like a map, and add default. So if I wanted to do, everything has to have environment is production or whatever I wanted to have, you can define that this way. By having a default variable, it means these are optional. So these are just regular Terraform resources as we had earlier. Sorry. And this is going to create 3 subnets, so a database, a backend, and a front-end subnet in the given resource group, in the given location, and with this prefix. We then have the same thing for the virtual machine. In fact, that reminds me, because this is a virtual machine, they take a little while. So I'm just going to kick this off while I'm explaining. Sorry, should have thought of that. Come on. Just to explain this. So where there's a Terraform module, Terraform prefixes the start of this identifier with module.name. So in this case, if we come back to the main TF, we have a module with the name of virtual machine. So this could be virtual machine, I don't know, whatever, or it could be a collection of, it could be a module that calls other modules. Terraform modules are really flexible, so you can basically do what you want with them. So you could build up like a module for your API if you wanted, or a module for a server type or a function app or whatever it is. So I was going to go ahead and create that. We're going to let that do its thing. Yeah, the virtual machine module is very similar. So we define a public IP address, again using the prefix location as before. We then create a network interface, which has a public IP address referenced above. And if we go to the virtual machine, this is just a standard Ubuntu machine with an OS disk and my SSH key, because that's convenient. Just to call this out while I'm here, the Terraform started splitting some resources out. So there are like a couple of different ways of defining things. You can define data disk attachments in line, similar to the way you can in like an ARM template, but you can also split them out into separate resources so it's slightly more readable. So we have a data disk attachment. So if you wanted to attach your disk to a virtual machine, as an example, you could do that like this, which is, yeah, quite readable. So whilst that's going along, hopefully that starts shortly. While that's going, yeah, Terraform supports all kind of things in Azure now. I've been on this for a couple of years, and we've kind of gone from just the infrastructure side to function apps to event hubs to, yeah. I was trying to do a talk earlier in the week, and yeah, everything I needed was there, which was nice. Come on. Sometimes they can take a while, apparently. But yeah, when this machine spins up, what we're going to do is just SSH into it, prove it works. We could, yeah, optionally change the prefix or whatever we wanted. Terraform would pick that up in the same way it has before. But this module could also come from the module registry if we wanted. So the module registry is at registry.terraform.io. That's very blurry. So if we search for Azure in here, there's a bunch of examples. So like a virtual machine as an example, or whatever it is you're after. That's not what I want, that's what I want. Okay, so we have a virtual machine now. So SSH that at that. Sure, why not? Come on. Cool, and we have a machine. Yeah, not overly exciting, but it's a virtual machine. It does what it says on the tin. Yeah. So yeah, Terraform modules, you can, as I said, you can specify many places. If you're storing your Terraform modules in a Git repository, you could apply semantic versioning to them. I know a few folks running tests with them as well. So they have acceptance tests for their Terraform modules. They provide them internally and then share them as they need to, which is quite nice. So just to summarize, the Terraform's DSL, the HashiCorp configuration language, allows for a common language to be used to provision any infrastructure on just about any provider. Terraform Plan will show you what changes it's going to make to your infrastructure, and then Terraform Apply will make those changes. You can run Plan and cancel out you can run Apply and cancel out at any point, which is quite nice. And when you're done, Terraform Destroy will tear that down, which is really handy for cost management. Terraform configurations can also be shared in modules for code reuse. As I said, there's a public module registry, there's a private one as well. Yeah, but you can write a Terraform module to do basically anything, and also chain providers together, which is quite nice. Cool. And with that, thanks. Any questions? Hi.
So here's Terraform is storing some state. Where does it store that state and how do you manage it?
So by default, I should repeat that. So the question is, does Terraform store any state, and how does it manage that? So by default, Terraform stores that locally. We recommend you store that on S3 or on AWS, on blob storage, sorry. Or there's a few options for that. Where are we? So docs, backends. So there's a bunch of documentation on the Terraform site about how to store that. If we go to, I'm just going to take this one as a simple example. Terraform stores some information about the resource, so it knows what the state of the world is. Sorry. Yeah. Basically, by default, it stores this locally. You can store this in blob storage in S3 and Terraform Enterprise and a bunch of other providers, or a bunch of other backends, sorry. Yeah. So when you do an import, it basically retrieves the information from Azure or whatever the provider is, and then stores that locally. If you use a backend, what Terraform does is to store that, to pull it from the blob storage container or from S3, do the work locally, and then push it back. So, sorry. Hi.
Question is, how is Terraform set up? So I look at the demo, I think Terraform you have to call one command line.
Mm-hmm.
If I want to do the CI/CD pipeline, sometimes I have to call one code, like Node.js or C# whatever.
Sure.
We have SDK something like that. SDK or SDK.
So we don't. That said, there are specific command line flags in Terraform. So sorry, should repeat that. Is there any way to, paraphrasing, is there any way to get Terraform running in a CI/CD pipeline without user interaction?
Yeah, without interface.
Yeah.
Command line.
So when I do Terraform Apply, one of the options here is auto approve, which will, just bypass the plan. So if you wanted to do that, you could. There's downsides to that. If someone's made changes and Terraform, I don't know, if someone's moved a location and Terraform says, hey, you can't do that, then Terraform will say, I want to tear that down and recreate it. Yeah. There are, there's plugins for different systems. So Azure DevOps has a plugin for that. TeamCity has a plugin for it. Yeah. At the end of the day, it's a command line binary, so you can kind of wrap it how you want. But there's no SDK officially for it, but there are command line options for it. Hi.
So what happens if you lose that state? What is it needed for?
So we use that for state tracking. Sorry. Yeah, so the question was, what does a state do? What happens if you lose it? So that is for state tracking. So at this point, you could import items back into the state using Terraform import. So basically, the state is required because if something is created, then, as I mentioned, there are some resources which can be created but not necessarily imported. So like an access token. I think S3 is a good, not S3. Some of the IAM stuff in AWS is a good example of this. Terraform uses that to keep track of the state of the world. You could pull this back together with Terraform import. But yeah, I mean, this is how Terraform tracks your infrastructure. So, did that answer your question?
Yeah.
Cool. Any other?
So, if I was to run Terraform plan and get it to spit out the plan,
Yep.
and then something else manually went to change the state of the world, or perhaps someone else ran Terraform Apply, and then I ran Terraform Apply on my now out-of-scope plan, what happens?
So, if you run Terraform plan or Terraform apply without saving the plan, Terraform will recompute it and go, hey, this did exist, it no longer exists, but now I want to recreate it. If you save the plan, someone else tinkers with it, and then you try and run apply with that plan, Terraform will recompute the state of the world and go, hey, this doesn't match. And so, like, I'm just going to fail and say you have to rerun plan because this is invalid. That's kind of why we run Terraform Apply, is why we run the plan as part of Apply now, is because we're doing the lookup there. So, yeah. Sorry, hi. So we don't have if else. Sorry. The question is, does Terraform support conditionals? So we don't have if else. We do have count. So an example, resource group is a bad example. Subnet would work. Give me a second. So one of the things you can do, in fact, manage disk is better. Sorry. Subnets have CIDR blocks and that gets complicated. So in this case, if I copy paste, which always works well, one of the options I can specify on a managed disk or on any resource is count. So I can say create 10 of these. And because in Azure the resource name needs to be unique, you're able to thread through through an identifier. So in this case, I'm going to do ndc disk count.index, which is like a special variable for the iteration it's running. Where was that? Sorry, that was in 1. So if I run Terraform plan, that's actually a really good point. So Terraform has gone and said there is no, you've referenced you've referenced a resource group with the identifier test, which didn't exist, and so Terraform has said this doesn't work, this doesn't compile effectively. It's not compiling, but it's building a plan. Anyway, semantics aside. So this is going to create, I think it was 10 disks, or we'll suggest creating 10 disks. You can set the count to 0, and that basically doesn't if else, or that basically will not create it. And you can have conditionals in there for if this is true in quotes, make this 5, otherwise make it 0. So variable example default high. So one of the options you can do in here, it's been a while since I've done this actually. 5 or sorry, in much the same way as any other language where you've got coalescing. So Terraform supports that. Come on. Cool. Hi. Yeah. You.
Can you use count with modules?
Not yet.
Oh yeah.
It's coming at some point. So we have some changes to Terraform syntax coming soon. TM. So we have a series of blog posts on Terraform's currently at version 0.11. There's the next version of Terraform coming called this next version of Terraform 0.12 coming. There's a bunch of blog posts around this, around some like changes to the syntax. Counter module isn't one of them, but it is something we want to do soon. 0.12 would enable that. Yeah. You can, however, pass another variable into the module, so call it number of instances, and then use that as the count if you wanted to internally on each resource. So you can kind of hack around it. It's just not, yeah. But we want to do it. Cool. Anyone else? Hi.
So with data sources, is it possible to create terraforms that will conflict with each other? So for example, if I create a terraform that created a virtual network and then a bunch of subnets, and then in another terraform I use that virtual network as a data source and then create a bunch of subnets, could the two bash against each other?
So, yeah, the question is if you try and create, if you have two instances of the same thing, will Terraform conflict effectively? Right now, yes. In the next release, no. There's a PR that fixes that. So specifically in Azure, like if Azure's APIs are upserts, so at the moment it doesn't error, we've realized that is not optimal, so we're fixing that. It's worth adding, there's two ways of defining like subnets specifically. Virtual network. There's the independent resource you've seen, but you can also define them in line within the virtual network. And if you do this, this will say only these three subnets can exist and nothing else. Whereas if you define them independently, you can say, I only care about this one subnet. I don't care about the rest of them. So if you want to guarantee that's the only thing that exists, you can do it this way. Otherwise, you can split it out. There's benefits to both. It's whatever works for you. Cool. Any other questions?
You mentioned Terraform Enterprise.
Yep.
What is that?
Terraform Enterprise gives you like workflow for teams. So specifically, we have something called policy as code. So it's called Sentinel policy as code. So you can say you're only allowed to deploy between 9 and 5, or you're only allowed these instance types, or whatever it is. It's basically workflow for teams. Grab me afterwards. We can chat. It's on the HashiCorp site too. Cool. All right. Yeah. Thanks.